Okay, video number 2. So this is your standard slide of fatty acids. So remember that triglycerides are the parent molecule. There's 3 fatty acids. And you don't see the shape right there, and this slide looks really complicated and bizarre. So if we just look at something more simple, I love this slide. So this is what your standard fatty acid looks like. And these look all straight. They're not. And I'll explain why they're not, but they look straight. So this is a standard fatty acid. It's just a chain of carbon. You don't need to know chemistry. It's covered in hydrogens. And when we see something like this, realize this is not a stick. These little bonds are all flexible. This really is a pearl necklace that you could lay in a box of other pearl necklaces, and they all would just line up, right? And these pearls are interesting because this piece of jewelry has little baby pearls on the outside, the hydrogens. That's a fatty acid. This is what our muscles burn for energy. When we release fat from our fat cells, this is what we release. When we break up fatty acids in the GI tract, this is what we absorb. This is your standard fatty acid. Now, since this is just a chain of carbons and it's loaded in hydrogen, we say it's saturated in hydrogen. This is what your solid saturated fat looks like. Now, this one below it is missing some hydrogens, and it has this weird bit of 2 lines going on here. In chemistry, again, you don't need to know chemistry. Atoms can make more than one connection with each other. They can handshake twice. This is called a double bond. And what happens is, for whatever variety of reason, it actually bends the molecule. The part that doesn't have the hydrogens is the bend, or the other way around. It bends. So anytime you see a double bond, it's a bent molecule. And since it's not loaded in hydrogen, it's not saturated, this is called unsaturated. Unsaturated fatty worms, pearl necklaces, are basically chains of carbon that just don't have all their hydrogens. They have its double bond, and it's crooked. Trust me, it's crooked. This has 1 double bond, so we call it monounsaturated. And in fact, if you looked in olive oil and you looked at the parent molecule in olive oil, the triglycerides floating around in olive oil, a lot of these little legs would be bent one way. They would have one little bend in them, because olive oil is a very good source of triglycerides that have monounsaturated fatty acids. If they have more than 1, now this has 3, it can have 2, 3, 4, 5, 6. Those are considered polyunsaturated. And if I said this is bent once, this is bent 3 times. Anytime you find a lot of double bonds in a chain of carbon, again, I'm not asking you to know chemistry. Just recognize what the shape is going to be. A really crooked molecule. If you had a pearl necklace that your kid had went and glued pearls together using super glue, and not all the pearls together lined up, but every now and then they glued the pearls together, and you go to wear that, it's not going to wear right. It's going to be crooked and weird. Same kind of thing. These are pearls that are bent, and so it puts a crook or a kink or a curve in the molecule. If this has one little bend, kind of like a V, this looks like a ship hook, a fishing hook. It's going to be bent a whole bunch. You can't stack things which are bent. You can stack things which are not bent. The reason why solid fats are saturated in nature, they don't have double bonds, and their triglycerides have 3 straight legs, and it's just really neat wood you can stack. And if they're crooked and bent like an olive oil, they're not going to stack, and it's going to be oil, not a butter. And another way to show this is right here, right? This is just a great example. Here's butter. Let's pretend butter has, these are the parent molecules, triglycerides, and these are just long chains of carbon. Here's one right here, palmitic acid. I think this is actually in butter, which is perfect. 3 of them. Look, it stacks. It's a solid. But olive oil is different. Look, they're all crooked and bent. Usually in olive oil, 2 of them are bent, and the one in the middle is straight. But I don't know whoever drew this, whatever. I forget which textbooks I stole this from years ago. It's not actually done correctly. But in any event, these aren't going to stack. This is wood that you go camping with. It's not wood from Lowe's. It's bent pieces of logs that you find in the yard or you buy from a local woods person that's selling wood. It doesn't stack. It's a disaster. You have a big pile of wood and that's it. That's olive oil. Just a pile of triglycerides that won't stack, and they're all kind of bumping into each other and floating around. It's the fact that there's bends. The unsaturated fats are crooked and the saturated fats aren't. And once you understand that, you understand why when you cook steak, you can see the fat. But when you cook chicken sometimes, the fat literally melts right off. Because chicken is fairly unsaturated. Yes, it may be solid before you cook it, but add a little heat, it melts away. With beef, it's so saturated, it stays solid even after you heat it. And I'm going to end there. That's enough for this one video.